Hello, my name is Larry Nairn and welcome to the presentation of the Application Submission System app project, currently under development by the Solus Binary Linguistics team. Team members include myself, Taylor Fuller, Jeanette Reeser, and Ryan Schultz. The project mentor is Dr. Kevin Gary, the Software Engineering Program Chair. In this presentation, the team will describe aspects of the project to include motivation and need, goals and constraints, the development process, a use case diagram, data entities and models, the user interface, and system structure. Currently, the hiring process for TAs and graders consists of applicants completing and submitting hard copies of forms, and the use of several spreadsheets to manually track these applicants. As a result, different versions of spreadsheets can exist across faculty and administrators involved in the hiring process. To solve the problem, the teams will develop a web-based application that allows graduate students to electronically submit applications and forms. In turn, this will offer faculty and administrators a workflow management tool that will facilitate communication to all parties, capture TA and grader application states, and expedite the hiring process, all in one location. For this project, the team has set goals and identified constraints based on the context of an online project. At completion, the team plans to deliver a quality software product to the project mentor, as well as receive valuable learning experience in the realm of software engineering. We also understand that in order to achieve these goals, we must communicate effectively in order to promote a common understanding of project details and tasks among all team members. Throughout the development of the project, the team plans to adhere to quality standards and policies. Coding styling standards have been put in place, as well as testing strategies and processes to conduct code reviews. All workflow will be facilitated through GitHub as a version control tool and through the use of a Scrum board to manage tasks during each sprint. Overall, our mentor will have final approving authority over new code and functionality that is planned to be added at the end of each sprint. Our project includes development of both client-side and server-side components. To do this, we use RESTful API-driven frameworks that incorporate the use of Ajax. AngularJS will be used on the client side, and the Express framework for Node.js will be used on the server side. Data will be maintained by a MySQL relational database. Overall, development will follow closely to industry best practices. Therefore, our web app will follow a variation of the model view controller design pattern, which will be described later in the presentation.
Hello, my name is Jeanette Reeser. I will be presenting the user interface for the application submission system that we are developing. The intent for this project is to gather information from the applicants so they can be screened for employment as TAs or graders. For privacy and security of the user information, all applicants must log in with their ASRAD ID and a password of their choice on the sign-in page. First-time users will select and create link and be directed to create account page where they put in their identifying information. If the users enter an invalid information or leave required fields blank, they will be shown which fields need to be addressed. The password field will have additional restrictions of 8 characters or more, upper and lower case letters, 1 number, 1 special character, and cannot be the same as their ASU Blackboard password. If the user happens to forget their password, they can select Forgot Password link on the login page, and they will be sent an email with a link to change their password page where they can reset it. Once the user decides to change their password, there is no need for them to remember their old password because it will be auto-populated but hidden for them. After they put in their new password and click Change Password, they will be redirected to the login page. Users who have already logged in can then start their application. Their information from the account creation will be auto-populated and they will be able to provide their address and phone number. At the top left of the page, they can see where they are in the process by the breadcrumb. The next step in the process is the education page where the user selects their degree program and enters their GPA. If the user chooses PhD or Master's Other, the page expands to allow them to enter the name of their program. After entering their education information, they can upload the IPOS or transcript. This is the employment page where the users can identify their desired time, commitment, and position as well as upload the resume. On the availability page, users can enter their times they are available to work for this semester and the next semester. This is the language page where the users specify which languages and tools they are familiar with. Finally, the users choose which courses they are knowledgeable in from the preference page.
Hello, My name is Taylor Fuller. This is a use case diagram for the web application. We have student, faculty, human resources, administration, and program chair as actors. Program chair is also administrator for the system, which is why they have the admin tool, the use case content management, which allows them to edit content in the web application. They also create all accounts for non-students, which are administration, human resources, and all faculty members. They also have the ability to do database searches, make assignments, since they have final decision for hiring TAs and graders, and also generate reports, which would be which courses still need TAs and graders, and which students have been assigned to which courses, just some examples. Administration can view application status and application artifacts. Human resources would generate the formal offers for TA and grader positions. Faculty have the ability to request a certain student for a TA or grader position for their class, and also submit performance evaluations. Students are set up where a new student would create an account and then start a new application. Existing students would log in and could either view application status or continue an application they have already started. Now, all users are mapped to login because all users need to log in. Once they are logged in, they would go to different home pages per user. Data entities and models. Entities include student, faculty, administration, human resources, program chair, application, attachment, and course. Program chair can view many applications. Faculty can view many applications. There would be many courses mapped to one application. Human resources can view many applications. A student would be mapped to one application. They cannot have many applications in the system, only one. Application can have many attachments, such as a resume or transcript.
My name is Ryan Schultz, and I will be discussing the system architecture of our application. After much research into the different architectural patterns, the team decided that a hybrid of the patterns would best suit our architecture. This pattern is called the Model View Whatever pattern, or MVW. We came to this conclusion as our application cannot strictly adhere to any one pattern, so we chose to use whatever works for us. Our chosen architecture is similar to the MVC pattern as it does contain a view, which is the user interface described in the previous slides, a model that represents our data, as you can see here, and a controller, or in our case, a whatever, that will manipulate the model, which in turn updates the view that the user will see. All of the components you see here are detailed in our software design specifications document in section 6. In this slide, you can see how each component of the architecture relates to another. Every data component of our architecture contains a type of controller that can manipulate that data entity. For example, the data component user has a user management controller that can manipulate the details of each user, as well as add or remove a user. All other data components will have a similar controller. Here's an example of how the architecture will be used based on a user logging into the system. When a user accesses our application, they will be shown a sign-in screen. On this screen, the user enters his or her login information and clicks the Sign In button. The application will then access the security component and call its login function. The login function will then access the password management component to retrieve the password associated with the user-entered user ID. After retrieving the password, the login function will compare that retrieved password to the user-entered password. If the passwords match, the login function will then access the user management component to retrieve the user whose account landing page will then be displayed. If the passwords do not match, the attempts variable will be incremented. If the attempts variable reaches the number 3, the user account will be locked and an email detailing how to unlock their account will be sent.